All right, so now let's get into our next section here. We're going to be talking about implementing MGCP gateways, Media Gateway Control Protocol. We'll start by kind of doing an introduction of MGCP. Actually, I'll talk about MGCP a little bit so we can have an idea a little bit about the protocol itself. And then we'll talk about really what an MGCP gateway is. We'll talk about MGCP gateway implementation. How do we choose or reference the MGCP gateway in our path selection in Unified Communications Manager? What is a route group? What is a route list? What are route patterns? Which are not directly related to an MGCP gateway, because certainly route patterns and route groups and route lists could reference any media resource or any media gateway. But this is a good way to introduce that. And then we'll talk about how do we perform digit manipulation in Call Manager so that when we do send the call to the gateway, that it's being presented correctly in the right format and so on to the PSTN gateway. So that's an important concept. As a protocol itself, MGCP is a call signaling protocol, call control protocol, right? For, generally for voice over IP communication systems, and it provides a call control function. It is very similar to what we would see in the structured PSTN format, very similar to other voice over IP control protocols like H323 and SIP, but MGCP is a specific protocol for gateway control, right? It is a text-based protocol with various commands and various responses. It does use the session description protocol as part of it to specify and negotiate the media streams that then ultimately would get transmitted using the real-time protocol. The MGCP architecture is defined in RFC 2805, and I did talk about this a little bit briefly before. It is a master-slave protocol where the media gateways are actually going to be controlled by the call control agent, in this case, Unified Communications Manager. So the gateway itself has very little configuration, and most of the control and most of the configuration is actually going to occur on the call agent, in this case, Unified Communications Manager. So we can specify ports that exist on the gateway, but it does provide us the ability to do central administration and kind of moves the control all the way back to Call Manager. Some people like that. Some people prefer to have the control on the gateway itself. And in that case, you wouldn't want to use MGCP. You would want to use H323. All right? There are basically three essential components to MGCP, what we call the elements of communication, if you will. The Media Gateway Controller, which is the Call Manager, in this case, the call agent. The Media Gateway Endpoint, and then the connections between them, which is the transport network, so or IP in this particular case. All right, so like I said, MGCP is a text-based protocol. Most of these control protocols are going to be text-based with a command and response model. The commands themselves get encoded in different types of messages, and they're formatted in an ASCII format. MGCP uses port number 2427 and port number 2727 by default, but you can modify that as well. Now, we don't need to get into the specifics of the control messages that exist. We use what we call a 4-letter command verb in MGCP to control it. AUEP, for example, for audit endpoint, AUCX for audit connection, CRCX to create a connection. So these 4-letter command verbs are kind of representative of what they do, right? DLCX, for example, is delete the connection. MDCX is modify the connection. Or RQNT, what do you think RQNT is? RQ, request, NT, notification. Yeah. RQNT or NTFY. NTFY is pretty easy, right? Notify, right? So you may get to a point where you kind of have to troubleshoot the different message types that go back and forth. But overall, that's kind of a little introduction, if you will, to MGCP. So we see here it's an IETF protocol. It uses SDP, like I said, to describe the session and initiate the session. It uses UDP port 2427, 2727 to send messages to the call agent. Obviously, it's going to be important to understand those port numbers for security reasons. You may have to open up those ports.
Is there another port number?
Not that I'm aware of.
There's a test. Huh? Yeah, the test there.
Oh, yeah. There is an obscure port number that they do reference on the test, but it's not used with Cisco. These are the two primary port numbers that you'll see with MGCP with Call Manager. All right. Some of the key features, some of the key benefits of using MGCP. Simplified dial peer configuration, because really where are the dial peers configured? Well, we don't actually technically have dial peers, right? We use the dial plan in Call Manager. As with and conversely, with an H323 gateway, you actually have to set up VoIP and POTS dial peers on the gateway itself. A dial peer is a command line version of your dial plan. So it allows you to match numbers based on destination pattern, or there's various matching conditions, and then we can specify where that call is going to go and so on. We can apply class of restriction and whatnot. But we don't really have dial peers on an MGCP gateway, all right? Because the MGCP gateway relies on the dial plan that is configured on Unified Communications Manager, all right? And again, that may not always be considered a benefit because you get less control at the gateway level. So if you want to do digit manipulation, if you want to do dialing restrictions, at the PSTN level or at the gateway level, MGCP may not be your best choice, for a gateway. Migration paths. If we have earlier versions of the protocol, we can easily migrate to MGCP. But I mean, typically we're just going to have kind of the modern MGCP protocol anyway. Like I said, a centralized dial plan, because the entire dial plan is configured on Unified Communications Manager, which again could be a plus or minus depending on what your objective is. Centralized gateway configuration. Again, there are a limited set of commands that get implemented on the gateway itself. Essentially, you specify who the call agent is, you specify that you want Call Manager to manage the gateway, and then you turn on the protocol. So it's literally maybe 2 or 3 at the most 4 commands that you execute on the gateway, and then the gateway pretty much downloads its entire configuration from Call Manager using TFTP, and it will you can actually debug and watch that process take place. The gateway gets its entire configuration from Unified Communications Manager. So very, very easy iOS configuration. Codec support, absolutely. It's a hardware device. We're going to have codec support. Of course, that's going to be limited based on the types and the numbers of DSPs that we have in the gateway, but the gateway will support multiple codecs as long as you have the physical hardware installed in the gateway to support it. Support for QSIG supplementary services. QSIG is an interesting concept. QSIG is a protocol or a signaling protocol that's based in the ISDN architecture, right? So it was typically something that we saw between the PBX and what we call the PISN, or the public switched or private integrated services network. And it's based on Q921 and Q931 signaling. Again, we don't really need to get into the specifics of the basic call functions and the generic call functions of QSIG. Just think of it as a physical layer, data link layer / network layer type of signaling mechanism for traditional PSTN connectivity, right? A lot of encoding and signaling methods that we might have.
We're at FedEx doing their migration from Avaya and Nortel TDM to Cisco. We had to set up a QSIG trunk between the Avaya.
Exactly, yeah,
and
right. And that's, you know, standard signaling in traditional PBX environments, yeah. We ran into the same situation. So you may have, for example, you may be migrating the phone system, but you may not migrate the voicemail system yet because you have a proprietary voicemail system, and so you would have to set up some sort of QSIG trunk to be able to communicate with those proprietary systems. So, all right. Now, as far as where the gateways sit in our environment, really anywhere, doesn't really matter, as long as they have IP connectivity to the call agent or the MGCP control agent, right? So Unified Communications Manager. So we can have gateways at each location. In the case of the right, we see a gateway, MGCP gateway with a PRI, primary rate interface connection to the PSTN. On the left, we see a residential gateway, meaning a home office type of gateway with an FXS port, which is a foreign exchange station port that provides dial tone, a DS0, and a FXO port, which acts as a trunk, a DS0 trunk to another phone system, and so on. All right. So again, we have this distributed system that is composed of the call agent, which is the MGC, the control component, and the media gateways themselves that do all of the conversions from, you know, the standard codec conversions. All right, so the call agent itself is a Unified Communications Manager, and it's going to terminate all of the MGCP control commands. Remember, we're operating in a master-slave role, where the call agent is the master and the gateway itself is the slave. So the call agent is going to have each endpoint configured, and there are some basic configurations within Call Manager to add the gateway. You're going to see that there are some specific requirements for adding an MGCP gateway in Call Manager that have to do with the naming of the gateway, how we identify the gateway based on its host name and domain name. And then there's some basic configurations within Call Manager to set up some of the general properties of the gateway itself. What type of switch type are we using? What types of ports exist on the gateway itself, what line cards exist, and so on, and interfaces and whatnot. So the call agent uses its directory of endpoints, the registered gateways, to establish the relationship between those endpoints, and then utilizes its own internal dial plan to determine how the calls get routed. And that's what we're going to talk about later on when we talk about route groups and route lists and route patterns. The gateways themselves just manage the PSTN to IP translation, just like any gateway would. Doesn't matter if it's SIP or H323 or MGCP. It's just a device that does that translation between the switch circuit network, which is our PSTN, traditional PSTN network, and the packet network. All right. By the way, the gateway has to report. It's the slave of the relationship, so it has to report all of the events that occur on that gateway, off hook, ringing, dial digits, etc., back to the call agent. And then the call agent makes decisions based on that. So you can have a residential gateway that might have some RJ11 interfaces. By the way, do you guys know the difference? I mean, clearly you know the difference between RJ11 and RJ45, but where do the numbers come from? They're just consecutive numbers based on the specification. RJ45 happened to be the 45th specification, and RJ11 was the 11th specification. Did you know that? See, you learned something. All right. Al Gore came up with that. Yeah, no, I'm kidding. And then we have... yeah. Well, that's all part of it. Yeah.
That guy's amazing.
Yeah. He was, you know, when he was at Xerox, when they came up with Ethernet, Yeah, and then he did some time with Intel, and yeah.
Oh, did he work on the DSPs too?
Yep, he did the DSPs, yeah. But, well, in the past 47 years, there was another guy that did everything too. No, I'm just kidding.
Not so much.
Yeah, I'm the guy, yeah. Anyway, but it is interesting. I love studying the history of networking, right? 3Com, everybody knows 3Com, right? Why is it called 3Com? Three companies, Xerox, Intel, and Digital Electronic Corporation. There were the three companies. They formed 3Com. Yep. Yeah. Xerox invented Ethernet. Ethernet 2, that we still use today, was invented by Xerox. IBM was betting on token ring.
That's a good technology.
Yeah. And Intel was betting on Ethernet. So they got in bed with Xerox, and Digital Corporation, of course, they were a big company at the time making bridges, deck bridges and whatnot to make LANs more efficient. And they got together. They're called the DIX Consortium, DIX Consortium. It stands for Digital Electronic Corporation, Intel, and Xerox, and they formed 3Com. Then you had the famous Etherlink 2 adapters and Etherlink 3 adapters. Yeah. Anyway.
Network didn't go very far.
Yeah. Well, it was good. It was good. But that was post ThickNet and ThinNet, right? With coax and all that stuff.
ENC connector.
Yep. So getting back on topic here, endpoints. Endpoints, of course, represent not necessarily phones. Endpoints would represent the interfaces, right? Is it an FXS interface? Is it an FXO interface? Because again, we're talking about the endpoints from the perspective of the gateway itself, okay? So when we're interacting with these gateways, we identify the endpoints with an address. So for example, if you look at the call manager configuration here, S1, SU1, DS1. S1 is slot 1, SU is subunit number 1, and DS1 is the digital signal circuit, basically the copper circuit. And then we actually reference the gateway by its host name and domain name, which is really important because if you end up changing the host name of the gateway, you're going to break your configuration. We don't reference the gateway by its IP address, we reference the gateway by its host name. But it's not we don't need to be able to resolve that host name because again, it's a client-server relationship. So when the MGCP gateway boots up, it does its TFTP request to call manager, and then call manager provides the configuration based on cross-referencing that host name and domain name in the configuration of the gateway and call manager, right? So depending on where you put the card, S1, SU1, DS1 is a T1 card, usually a VWIC. A VWIC is a voice WAN interface card. So that particular cable is plugged into slot 111. So on the back of the router, you have a VWIC. Maybe it's a VWIC 1MFT card or a VWIC 2MFT card. MFT is a multi-flex trunk. So it's a card that can act as a voice T1 or a data T1. And depending on where the card is inserted into the router will depend on how it's provisioned in Call Manager. So you literally build the gateway in Call Manager and you choose the cards that exist in that gateway, and then you can configure those interfaces based on the physical configuration of the gateway. Of course, it has to match based on how the gateway is actually physically deployed, has to match how you build it in Unified Communications Manager. So we identify the endpoints, the local name of the endpoint in the context of the gateway, of course, and the domain name of the gateway. The @ symbol kind of just separates those two parts. So the slash separates the subparts of the hierarchy, slots, subunits, and ports. But again, it it is something that it's not very arbitrary. I mean, it literally has to do with how the cards are inserted into the platform. So if you go into an ISR router that's acting as an MGCP gateway and you do a show inventory, you can see exactly what cards are in what ports and what designations they are for the slot and the subunit and so on. All right. So these endpoints do register to call manager, but again, it's not necessarily. It depends on the platform. It's not a predefined configuration. It just depends on the router, what kind of interfaces you have, and so on. All right. Now I did talk quite a bit about the concept of MGCP and all these different message types, how we use that 4-coded message, the 4-letter command verb is what they call it. It's again, these are a sequence of commands or requests, and the commands that get sent back and forth between the call agent and the gateway are called transactions, and they're basically identified by the numerical transaction identifier for each transaction that happens, right? The protocol itself specifies 9 standard commands that are distinguished by these 4-letter command verbs. And I'm not going to go through each of these in the text here. I don't think it's important for us to read through each of these, but audit and endpoint. So audit and endpoint is just a way for us to verify the status of the endpoint. Audit a connection, the status of an active connection through the gateway. So an active call, for example, on the gateway. All right, create connection, CRCX, a way for us to create or establish a connection with an endpoint. Delete connection, DLCX, a way for us to delete the connection, modify a connection. So alter the operating characteristics, if you will, of a connection. Maybe we're going to use a different speech encoder. Maybe we're going to mute the call. Maybe we're going to change the duplex from half duplex to full duplex and so on. All right. Another verb that we use is used by the call agent to request notification of events that are happening on the particular endpoint. Maybe this is to apply signals to the PSTN network link. And that's a request RQNT, or request for notification. Another verb that you might see that's used by the endpoint, not the call manager, but is used by the endpoint to indicate that the call agent has detected a particular event, and it's requesting a notification based on the RQNT. We're sending the NTFY. And then we have a couple of other ones. The RISP, or RSIP, restart in progress. They have that listed here as a message that notifies the call agent that the gateway and its endpoints have been removed from service or are being placed back in service. So you would actually, if you did a debug MGCP events, for example, you would actually see these verbs listed in the trace, in the MGCP trace, and then you can go back and kind of research what those messages indicate and so on. All right, so it's not something that you necessarily need to memorize for the exam, and I don't even really think it's something that you need to necessarily understand practically. It's certainly something that you can always look up or reference especially if you're doing some knee-deep troubleshooting and you want to be able to verify what these messages represent. But there are the 9 different message types, so it's going to fall within one of those 9 categories based on what's happening with the gateway itself. All right, there's lots of different RFCs that exist with, for the standards documents as well. RFC 3435, which is really the kind of the overall encompassing RFC. 3660, I think, is the packages RFC. There's a bunch of them. I don't remember what each one of them are, but several different RFCs for the protocol itself. All right. So we're seeing kind of a transaction or a set of events that are occurring here. Number one, the call agent sends the RQNT to each of the gateways because these are the gateways that are configured in Call Manager. And it's the idea is here is that we're instructing the gateways to wait for off hook. Off hook meaning that the line is seized, or the trunk is seized, or even the FXS port goes off hook. And if an off hook transition event occurs, the call agent then tells the gateways to send dial tone, right? Now that would only apply, of course, to an FXS port, but I think that's what they're kind of referencing in this case based on the diagram, right? So we're talking about a specific set of transactions based on the fact that those phones are connected to the gateways via FXS, all right? Clearly, we wouldn't play dial tone if a PRI line or PRI port is seized, but all right. So then we look to monitor for other events, right? Digits maybe being pressed or whatnot. The gateway responds to the request, and now we're waiting basically for a triggered event. So let's say user on the left gateway, gateway A goes off hook. We're instructed by the call agent based on its earlier request that the gateway provides dial tone. So it's providing dial tone because the gateway is provided with a digit map, meaning a way to collect digits as they're dialed. So collecting the DTMF tones and whatnot. Either we match the digit map or we don't match the digit map. So in this case, obviously we're assuming that the digit maps were matched because we're going to proceed with the call. All right, so gateway A then in step 4, actually the third arrow in this particular case, sends the notify to the call agent to advise, basically tell the call agent that the request event was observed, meaning the off-hook event. Notify identifies that the endpoint in this case now is dialing digits, and we're going to send that information. And then based on the dialing digits, based on the digits that were dialed and captured, we identify whether or not the call can proceed. The call agent says, yes, the call can proceed. So it basically tells the gateway, the CRCX, which is connection request, to the endpoint. The gateway then responds with the SDP information, the session discovery information, if it's able to go ahead and facilitate the call. And that session description information identifies the IP address, the UDP port. Again, these are all of the characteristics of the RTP stream that needs to be established. All right. The gateway itself doesn't have the session description information for the remote side of the call, so we're going to kind of go into a wait state. All right. So we send that SDP information. So we're kind of right here at this point. We've already collected the digits. This is where the SDP information is sent. And now the call agent is now instructing the other gateway that events are occurring. Again with the CRCX. And we have a request notify. In other words, tell us how you're going to handle this. We get the ringing. The person picks up. We acknowledge the connection request, and we send the session description information in the call. All right. Why is it important for that SDP information to be passed by both gateways to the call agent? What kind of things are included in the SDP that are important? You guys remember? Yeah, I mean, the session description protocol is what actually allows us to identify the parameters of the RTP stream, right? It's a way for us to negotiate the multimedia communication session. You know, what type of codecs are we going to support? How we, you know, what are the components of the call? And there's a bunch of different things that kind of fit within that SDP information. We got our session description information. we got our time description information, and we have our media description information, right? And we can get into all the different attributes and the character sets and whatnot, but I don't think that's really that important. I know they do have some questions on the test about STP information. They do have some outputs that talk about STP, but to me, that's memorization. Because if you're capturing debugs and you're looking at STP information, you're ultimately going to reference some documentation to be able to identify what those values are, right? For example, ILBC codec is, what, 89, I think it is, something like that. You're not going to remember that. Maybe have to go look it up or whatever.
So
okay.
The call agent is...
Call manager.
Well, the call manager is actually has a session in both gateway A and gateway B at the same time?
Yes,
Like
those are gateways. Well, it's not a proxy. Those are gateways that are registered.
There's a stream on one side and a stream on the other side, and all traffic goes through the call manager.
Negative. The streams themselves are established. Yeah, the RTP streams themselves are established between the gateways.
But
All the other control stuff.
Control stuff does go through.
Yeah, all those arrows, RQNT, NTFY, those are all my MGCP commands. MGCP gateways cannot communicate directly with each other. They have to go through the call agent. So the call agent is the master.
What was Mike's question again?
He was asking, is the call agent acting as an intermediary, right? He used the term proxy, sufficient, right? Because the gateway on the left is not going to be able to communicate with the gateway on the right directly. Not with MGCP. We have to communicate through the call agent. All right. So we progress through. I don't need to go through the rest of these bullet points, but the communication and the interaction, I think, is pretty straightforward here. When we go on hook means you hung up the phone. You get a notify, you get a delete connection request, delete connection response. And there's actually more messages that are being sent back and forth. This is kind of simplified, to give you an idea of just the transactional nature of the gateway and call manager. That's really the main thing. We're just trying to identify this relationship between the two. Okay? So how do I implement my gateway? As you can see from the gateway's perspective, it's pretty straightforward. All right? CCM manager config-server, CCM manager config. So we're identifying who the call agent is. We're saying that we're going to go ahead and allow the gateway to be configured by call manager. Step number 1, of course, set up the gateway in call manager. Step number 2, call manager creates files for the MGCP configuration for the gateway based on how we added the gateway to call manager. The files get stored in the TFTP server. These are just XML files, just like we have with phones as well. And then step number 3, we set up the gateway. Step number 4, the gateway pulls the configuration. Now there is something missing here. We still have to enable the protocol. MGCP enables the protocol. But I think they're assuming that's kind of already been done at this point, right? So every MGCP gateway gets associated to call manager. They didn't really show us how we provision the gateway in call manager, which is a little bit disappointing actually, because there are some critical pieces to that. Number 1, the gateway has to be provisioned based on the host name of the router and the domain name. You guys are going to be doing a Discovery 12, implementing PSTN calling using MGCP gateways, so you will see this configuration there, and I think that's the idea, is that you're going to see the whole detailed configuration when we get into the Discovery. But there are some specific requirements for identifying the gateway and call manager. You can't just arbitrarily pick a value and say that's the value I'm going to use. All right? But each gateway is going to have its gateway specific configuration stored in call manager based on that configuration. If there are changes made in call manager, in the database. Those messages then, there are messages then that get sent to the gateway to indicate to the gateway that your configuration changed, and then the gateway is going to trigger a download for the new configuration. All right. Another important concept in with these MGCP gateways is something called PRI backhaul. MGCP supports call manager configurations. We know that essentially all of the control of the MGCP gateway is done with call manager, and there are a whole bunch of different types of interfaces that we can support. We could do PRIs, we could do T1s, T1 CAS, T1 CCS, we can do FXO, FXS, and so on. And we also know that the gateway itself pulls its MGCP related configuration from the call manager TFTP server. All right, which means that we have a centralized configuration. We don't have to worry about really too much configuration on the gateway itself. The call manager supports what we call PRI backhauling. Now you have to understand that if you look at the diagram, it's actually pretty self-explanatory, right? Q921 is the ISDN signaling for layer 2. So you have a layer 1 component which clearly can't go back to call manager, and you will have a layer 2 component which is establishing the framing and the layer 2 framing of the PRI. The logical control of the PRI is done with Q931. Q931 is really the control of the ISDN circuit. With PRI backhauling, the MGCP gateway passes that ISDN D channel control. ISDN circuits are based on what we call B channels and D channels. A B channel is the bearer channel. Those are the DS0s that carry the audio. And then the D channel is the data channel, which is essentially responsible for the logical control of the channels themselves, the multiplexing, the seizing of the individual DS0s, and so on. So PRI backhaul is just a fancy way of saying that the gateway doesn't control Q931, call manager controls Q931. All right, so we have a backhaul interface between call manager and the MGCP gateway, that separate channel for backhauling that signaling information. So all of the layer 3 PRI Q931 traffic gets backhauled over a TCP connection, and then that layer 3 information is forwarded independent of the protocol that's used on the actual physical interface, the time division multiplexing interface. All right, and PRIs are unique, right? PRIs are unique because they require both layer 2 control and layer 3 control. So not like a traditional analog circuit or whatnot, okay? So the D channel is the channel that carries that control information. That is going to be carried back in its raw form, so unedited, unmodified, to call manager for processing. The gateway doesn't change any of that signaling information. It doesn't intercept that signaling information. It just passes it back to the call agent, and that's where TCP port 2428 comes into play, right? The Q931 backhaul. So that's why they mentioned 2428 on the test. If you didn't have a PRI, that port would not come into play, all right? So the gateway is still responsible for the layer 2 termination, right? So Q921, the data link layer connection, gets terminated on the gateway, but everything above that, Q931 and the payloads and everything else, that gets passed back to the call agent. The gateway doesn't actually bring up the D channel, all right? That also means, by the way, if there's a break in communication between call manager and the gateway, the D channel won't come up, all right? And you need that D channel up in order for that communication to take place. All right, what are some of the other considerations? If the gateway has failover, You can use the CCM Manager fallback MGCP command to specify essentially a subscriber or secondary server. If there is no failover, obviously that's not going to do any good with regard to redundancy. All right, but typically we'll have a primary call agent and a secondary call agent for the gateway itself. So what about the path selection? We kind of talked about this a little bit, very briefly. We looked at it, the Visio diagram, the flow chart and whatnot. Call Manager, Unified Communications Manager, has a very specific way of matching or routing calls to the PSTN or to a trunk, and you know, even an IP-enabled trunk itself. We create the route pattern, which is a PSTN dialing pattern. That route pattern, in the route pattern configuration, you know, we can do transformations and translations and whatnot, but it points to a route list. You cannot point a route pattern directly to a route group. The route pattern has to point to a route list. A route list is an ordered list of route groups, meaning that top-down processing. So the first group in the list is going to be processed first. The second group in the list is going to be processed second. And guess what the route groups point to? The route groups point to trunks and gateways. So in this particular case, we can see that the route list points to route group number 1, which goes over the WAN, and then the backup is route group number 2, which goes to do 2 different voice gateways. One voice gateway might have a PRI, the other voice gateway might have a T1 or analog ports or whatever it might be. All right? You see the big blue arrow? Right? The big blue arrow indicates how you have to configure these things. These are what we call dependencies. You can't configure a route list until you have route groups. You can't configure route groups until you have gateways. You can't configure gateways until you have the physical hardware, right? And the cards and the physical configuration. So whenever you're looking at that Visio, which I will provide to you guys, but whenever you're looking at that Visio, you always kind of configure everything backwards. Another example would be like a hunt list, right? A hunt pilot points to a hunt group. A hunt group points to a hunt list. A hunt list points to extensions. So you want the extensions first, then you can configure the hunt list, then you can configure the hunt group, then you configure the hunt list, and then you configure the hunt pilot, right? So it's the same kind of concept. I think you guys have a good idea of what a route pattern is, right? You can point a route pattern directly to a device, like a trunk or a gateway, or you can point a route pattern to a route list. If you point, it's really important, if you point a route pattern to a trunk directly, like a SIP trunk or some other trunk, or you point a route pattern to a gateway, that gateway or that trunk can no longer be a member of a particular route group. So when you go to create your route groups, you're going to see a list of available devices that you can choose from to put in the route group. If there is a device that is already pointed to by a route pattern, it won't show up in that list. So that's a pretty important thing to understand. You can't have them in both places. Right? The route list is just a level or a path selection, like you can see in the diagram here, a list of route groups. It is an ordered list. Like I said, it is processed from the top down. Route groups themselves don't necessarily have to do top-down processing. A route group can be configured to process in a circular fashion or in a top-down fashion. It depends on how you do it, right? I always recommend, and Cisco recommends as well, even if you only have one gateway or one trunk, create the structure. Put it in a route group, put it in a route list, and then always reference the route list, because that's what gives you the flexibility later on of adding other route groups or adding other devices. I see too often that somebody will get lazy and they'll say, we only have one PR or one SIP trunk. So I'm just going to point all my patterns to the SIP trunk. And then all of a sudden the customer says, well, we added a PRI. Now you have to go back and remove that dependency of that SIP trunk on all your patterns, and then you have to create the structure. So just create the structure in the first place, right? It'll make your deployment much easier to manage later on down the line. All right? So, I mean, what is a route group? I think you guys get the idea. A route group is a group that points to interfaces or trunks on a gateway. All right? Like I said, you can configure it either in a round-robin fashion, or you can configure it in a priority-based fashion or top-down fashion. All right, now think about this from the perspective of 911. All right? So let's say, for example, I have 4 sites. And LA, Boston, New York, and Atlanta. All right? So, and each one of these locations has their own PSTN connection. Theoretically, well, we're going to talk about local route groups in a second, but without local route groups, if I wanted to route calls locally, my dial plan would get rather complicated because I would essentially have to duplicate my dial plan 4 times, my PSTN dial plan 4 times. Does that make sense? So if I had 911, I'd have to have a pattern for 911, which would then go into the ATL emergency partition, and then I would have to have an ATL search space that includes that pattern, and then this pattern would point to the ATL gateway. Make sense? And then I'd have to have the same thing for Los Angeles, the same thing for Boston, the same thing for New York, and then if I had long distance patterns and so on. All right? Which means that essentially I'm duplicating my effort. Every time I want to create a pattern, I have to do it. And if you have 10 sites or 15 sites, it gets really bad. All right? So what Cisco did is they came up with this concept of a local route group. And a local route group decouples the selection of the gateway with the actual pattern itself. It allows you to use the same pattern for multiple gateways by identifying the location of the site. So I can say, okay, this gateway is going to go into the local route group of Atlanta. This gateway, let me go back to my notepad. So this gateway is going to go into the, so I have a local route group for LA, I have a local route group for Boston, I have a local route group for New York, and I have a local route group for Atlanta. So rather than having the 911 pattern point to a specific gateway, I can say, let me just create one emergency partition and one corporate CSS, and then the pattern points to the local route group. So based on your location, based on the device's device pool, will determine what gateway that call is going to go to. But I only have to create the pattern one time. Right? If I go back to my Visio here, you can see that based on the device pool, where it is right here, based on the device pool, we have a location. And if you look at, let me see, I think I have it on here. Right, but yeah, local route group, right? And a local route group points directly to a route group that contains the gateway, right? So, and you see that in the diagram here as well. The diagram kind of describes it pretty well. Let me minimize this. All right. The diagram looks a little confusing, but it's not too bad, right? So the call manager, we actually set up the local route group. That's based on the device pool configuration. So I would have an Atlanta device pool, I'd have an LA device pool, Boston device pool, and so on. So I wouldn't have to duplicate the pattern each time. It's a really, really simple configuration actually. So rather than route the call to a route list, which points to a physical gateway, I'm just going to go ahead and say use the local route group. Hopefully you guys will be setting that up in Call Manager for your discovery, right? So depending on the device pool will depend on the route. The route list itself will have just a generic statement that says, let's go ahead and use the standard local route group. So here's kind of a picture here, and this is really what I wanted to kind of show you, is you've got your route list configuration. The route list registers to the call manager. You give it a name, give it a description, which call manager group, so that's your primary, secondary, tertiary call manager it's going to be registered to. And notice for the route group, rather than picking like a customized name route group or whatever, you're just going to pick the standard local route group designation. And then when you go into the standard local route group, that's going to be based on the gateway for that particular location, based on the device pool, right? So you don't actually even reference a gateway directly. It's all based on the device pool for the gateway and the device pool for the phone. So basically what Call Manager is doing is saying, okay, what's the device pool for the phone? What's the device pool for the gateway? If they match up, that's where the call is going to get routed to. Does that make sense? So you have your Atlanta device pool, you have put the gateway in the Atlanta device pool, put the phone in the Atlanta device pool, and it's going to use the gateway for that device pool. All right? But the key here is that you can reduce the number of patterns that you have to create significantly in Unified Communications Manager, especially if you have lots and lots of locations, right? So basically we're just doing dynamic selection of the egress gateway depending on what device originates the call. So we have generic route patterns that point to the route list that just points to a standard local route group, and then based on the device pool configuration, that call routes to that particular gateway. Okay? Pretty straightforward thing to understand. Not too difficult to configure either. Now, as far as route lists and route patterns, route lists point to route groups point to devices. Guess where the pattern points? The pattern points to the route list. So in this particular example, we have a pattern of 9.14108.5264XXX. That points to the route list, and then we have our first choice and second choice in the group. The route pattern itself, when you define the route pattern, you can actually specify where the route pattern gets routed, what numbering plan it's going to use, which we generally don't change, by the way. We just use the Call Manager numbering plan. They're doing a 9.at pattern, which is old school. Well, I don't know, if you're doing globalization, it would probably work, but I don't typically use the 9.at. 9.at is like every pattern. You just have one pattern that matches everything, right? And notice they're pointing it to the HQSIP route list, which is just a custom route list that they created called HQSIP. Notice they also classified the call as off-net. You can also say we're going to route this pattern or we're going to block this pattern. Pattern would probably go into a partition. You'd probably give it a description. But the point is that the pattern itself points to a route list. Notice it says gateway route list. Okay, so you can point a pattern directly to a gateway. But again, if you do that, that gateway can no longer be a member of a route group. You can still reference it from other route patterns. It can be referenced by more than one route pattern, but it could never be a member of a route group. Okay? All right. With regard to digit manipulation, I think we pretty much have a good understanding of when I would want to manipulate digits, right? Do I want to strip off an access 9 code? Do I want to add a 1 for long distance? Or do I want to strip off a 1 for long distance? You know, what am I trying to do with the digits? But not only can we manipulate the digits, we can also manipulate how the call is presented. In other words, what is the type of call? When you're doing ISDN, for example, you might identify the call as national or long distance or international because the carrier might need that. So let's say I'm doing a call from the internal network to the PSTN. Well, the internal network means the call is coming from my internal extension. I don't want my ANI to be my internal extension. I want the ANI to be an E.164 number. So if somebody's looking at their caller ID or they want to call me back, they're going to get my fully qualified E.164 number. So we can do calling number manipulation on the gateway. We can do it at the phone level as well to expand my extension to the full E.164 number. So I'm representing my number appropriately. Internal to PSTN, oftentimes I'm also going to be stripping off an access code. You will see a reference to access codes almost always as a 9, but it could be any number. Doesn't have to be a 9. It could even be multiple numbers. You don't necessarily have to just use a 9 for an access code. Internal to internal. Maybe I'm dialing 0 for the operator, but I want to expand that to the operator's extension. That's more of a translation, but it's still the same concept. PSTN to internal. Maybe the PSTN called party is the directory number, or the called party was the E.164 number, and I need to somehow translate that to the internal extension, and so on. So there are many reasons why we might want to manipulate a particular pattern. Okay? These are just some examples. There are actually other examples that exist as well. So it can be a little confusing because there are many, many places that you can manipulate the pattern itself. You can manipulate it on the gateway. You can manipulate it on the phone. You can manipulate it on the route pattern. You can manipulate it at a translation pattern. On the route list, you can manipulate it. So this basically identifies all the blue boxes indicate where we have the ability to manipulate the patterns. But it also depends on how the call is proceeding. All right. So you can see from this graphic, it is a little bit confusing, but let's kind of break it down a little bit. Let's start with a call that comes from the gateway, or a trunk, an inbound call, or even from a phone. All right. The first digit manipulation option that you have, actually for ingress calls or at the ingress gateway or the trunk, you can actually modify the call as it comes in on the gateway or the trunk. So you can do like incoming calling party prefixes. You can do digit stripping in this case. You can do transformations based on a transformation CSS that is applied to the gateway itself. You can even modify the calling party. All right. Now the called party can be modified. You could do significant digit mapping. So you could say, okay, I'm sending in 10 digits from the gateway, but the significant digits are 4. So only the last 4 numbers matter on the call. That's pretty common when you're dealing with like DID numbers, where you have a call coming in, you're dialing a 10-digit PSTN number, and the DIDs, the extensions, happen to map over to the actual DID, where you can just do significant digits. You can do a prefix directory number, incoming called party transformations, by adding prefixes, again, stripping digits, performing translations, and so on. All right? You cannot do any digit manipulation for calls that are placed from a phone itself. All right? Unless what you're dialing is referencing a translation pattern or some other place where you can do the manipulation. All right? Excuse me. You can manipulate these numbers in all these different places and all these different locations based on calling and called party information. And they have various effects, right? Because you have to think of an order of operations. I place a call, Maybe that call is matching a translation pattern, so I can do digit manipulation on the translation pattern, and then the translation pattern points to a gateway, and then I can do additional digit manipulation on the gateway. So there's also a progression, right? One might trump the other. Gateways are generally the last place that you would make any kind of do any kind of manipulation, especially for outbound. Now for inbound, it would be the first place, right? So it just depends on the direction of the call and so on. All right. Let's say, for example, a call number matches a directory number on a phone. You don't really have to do anything to that call. If the called number matches a directory number, the call is just simply going to get processed and sent to the directory number. All right. It wouldn't really make sense to modify it. All right. But the calling party information, who is actually calling, you might want to modify. Because let's say, for example, I get the ANI information from the call. And the ANI information is the area code, prefix, and exchange. I mean, area code, prefix, and subscriber number, right? The 10-digit number. And I missed the call. I didn't pick up the call. And I go to my missed calls list, and I see the call on the list, but it doesn't have a 9 in front of it, doesn't have a 1 in front of it. So if I go scroll to that missed call and I hit dial, it's not going to work. So I have to do like an edit dial where I can put the 9 and the 1 in front of it and place the call. Maybe I don't want my users to have to do an edit dial when they're calling back a missed call, so I can do calling party manipulation to add the 9 and the 1 so that when it shows up in the list, I can just scroll to that number and hit dial and it'll call it back. Does that make sense? So there's all kinds of reasons why you might want to manipulate numbers inbound and outbound in the system. It really just depends on what you're trying to accomplish as to where you would actually do it. All right. So when the called numbers match things like translation patterns, if they match a hunt pilot, if they match a route pattern, then we can do all kinds of manipulation. We can do called party transformations, and we can do calling party transformations. Called party, who was dialed. Calling party, who's doing the dialing. Or more technically speaking, called party DNIS, dialed number identification service. Calling party ANI, automatic number identification. All right? And then, we could break down, I suppose, the whole chart here, but it's more for reference, right? Because you have to understand, for example, a translation pattern could point to a gateway or a route list, right? Well, I might decide to do discard digits on that translation pattern. Maybe it's a 9-dot translation pattern or whatever. All right? So here's a kind of an example. The extension 1005 dials 91-303-555-6007. So we already know one of the manipulations that we're going to want to do, right? We're going to get rid of the 9. Maybe this particular, and it's listed right here, maybe this dialed number matches the 9-bang route pattern, which is a really horrible route pattern, but basically it's any number that starts with 9. But it's easy enough to reference here. So, but we want to do the pre-dart discard. So within the pattern itself, we do the manipulation. Within the route pattern configuration, we do the called party manipulation. We say, okay, discard digits, anything pre-dot, and then the calling party transformation is to say, take the last 2 digits of the extension and superimpose those last 2 digits of the extension, or prepend, I should say, the last 2 digits of the extension with 408-55530. Whenever you see a wildcard transformation, the position of the X's in reference to the original number is always from the right to the left. So these 2 X's represent the 0 and the 5. Those 2 X's right here, these 2 X's right here represent the 0 and the 5 here. Make sense? It's always from the right to the left, not the left to the right. So call manager basically strips off the 9 because that's what's before the dot in the pattern, and it sends the call as 1-303-555-6007 to the PSTN through the gateway, whatever gateway is being referenced by the route pattern, but it also modifies the calling information to 408-555-3005. All right? Which means that the phone on the PSTN is going to see the appropriate number. What about for inbound? What would be an example for inbound? In this particular case, a PSTN phone dials 1-408-555-3010, which is a DID number routed by the global PSTN people to my gateway. Okay, so the gateway receives the call. Of course, we want to be able to route that to extension 1010. So it looks like in this particular case, only the last 2 digits of the number match the DID. So we're going to have to do a called dial or a dialed number transformation, right? Incoming called number needs to be translated so that we can take that 408-555-30XX and we can add a 10 in front of it. So that's the called party transformation, 10XX, and again, that XX directly relates to the last 2 digits of the number that was dialed. It's always from the it's always from the right to the left. And we're going to go ahead and change the calling party, and we're going to prefix a 9-1. We can't prefix a dot because we're not actually changing the pattern. The dot is only in the route pattern to match for the pre-dot discard. But I already described why I want to put the 9-1 in front. I don't have to. Doesn't affect call progress. The call is still going to connect. That's why they say that's an optional parameter. But if I prefix the 9-1 in my call logs, I can just do a direct dial. I don't have to do an edit dial to call that particular number. Make sense? So call manager is going to see the 408-555-3010. It's going to translate that to 1010. Call manager looks up 1010 and finds the phone with the DN, and the call proceeds. Call manager then represents the call to the extension 1010, but it's going to prefix the 9-1 so that the call shows up. Okay? All right. Just a couple of basic examples of digit manipulation. Many, many cases where you would have to do this. These are just 2 different examples, but digit manipulation happens all the time and at multiple points in the system. All right, so now let's get into discovery number 12, implementing PSTN calling using MGCP gateways. All right, we're going to move into discovery number 12. Discovery 12 is implementing PSTN calling using MGCP gateways. Implementing calling to the public switch telephone network using MGCP gateways involves several different tasks. Some of them are a little bit more difficult than others to implement. And we have to configure things both on Unified Communications Manager and our iOS gateway. And we're going to start by configuring Call Manager, in this particular case, our HQ UCM platform, and our Cisco iOS gateway to support MGCP. All right. And then we're going to troubleshoot MGCP registration. We're going to verify the configuration. We're also going to implement inbound and outbound PSTN calling by creating a new dial plan and a new digit manipulation configuration on Call Manager. All right. We're going to implement the local gateway selection feature so that we can implement our PSTN calls utilizing the local route groups and whatnot. There are basically 3 phones that we see here, CIPC1, CIPC2, and we have a PSTN phone. All right, CIPC1 and CIPC2, those are going to be pre-configured on Call Manager. CIPC1 is located in the San Jose location. CIPC2 is going to be located in the Research Triangle Park location. We don't have access in this particular case to RTP GW or the PSTN GW, all of our configuration is going to happen here and here on Call Manager and the San Jose gateway. All the other configurations on the RTP gateway and the PSTN gateway, they're already actually done for us in this particular exercise. All right. Call Manager Express is also pre-configured on the PSTN gateway to accept register messages for the PSTN phone, and then the PSTN phone can be reached from the San Jose location through the San Jose gateway. There's going to be local calling that's established there for 408 2 through 9 XXXXXX. For the local line, there's going to be national calling for 1 2 through 9 XXXXXX on the San Jose national line. We're also going to simulate international dialing 011 exclamation on the San Jose international line, and then finally emergency dialing 911 on the San Jose emergency line. We have a similar setup for the RTP GW. Same thing, local calls. The only difference here is we're using the 919 area code. We still have our 2 through 9 pattern for national, 011 exclamation for international, and 911 for emergency. All right. Now the connections between the San Jose gateway and the PSTN gateway and between the RTP gateway and the PSTN gateway are all ISDN connections in this particular case. The connection between Call Manager and the RTP GW, that's going to be a SIP trunk. Again, this is already configured on both sides. We don't have to actually configure this. PC1 is running our CIPC1 at 5.200. PC2 is running CIPC2 at 5.201. PC3 is running the PSTN communicator, and that's going to be at 99.101. And our router is 5.252. Our Call Manager or Unified Communications Manager is 5.5. All right, so the first thing that we need to do, just as we've always done in all of our other implementations, is to make sure that we can go ahead and register the endpoints. So let's start by going to PC1, and we will log into PC1, and we're just going to verify the configuration of our CIPC application or Cisco IP communicator. So let's launch that. We'll try to go through this relatively quickly because this is a step. Every time we initialize the lab in this particular environment, these are tasks that we have to complete each time. Really, the only thing is just to make sure that the device name is correct. CIPC-1 in this particular case. We'll do the same thing on PC number 2. All right, so let's go ahead and log into PC number 2. And let's see, C0LL at B. And then we'll do the same thing on PC number 3 as well. All right. Obviously, in this particular case, this guy is going to be called CIPC 2, and then we'll have CIPC 1, and then the PSTN phone. All right, I paused the video there so we didn't have to watch that, but we got PC1 registered here, John at extension 11,001. We have Jane at extension 12,001 on PC2, and the PSTN phone is just coming up right now, and it's going to have all of those extensions that we use to dial to simulate those PSTN calls based on the configuration of Unified Communications Manager Express. And then these are all of the local, national, international emergency numbers, okay? So all our phones are registered. The next step is to go ahead and integrate a iOS MGCP gateway with Call Manager. MGCP gateway implementations include configuration steps that we're going to implement on Call Manager, which is acting as the MGCP call agent, and the MGCP gateway that we're actually going to be controlling. The steps to actually configure the gateway are going to differ depending on the type of MGCP gateway platform that we're using, but for the most part, the steps are going to be very, very similar. In this task, we're actually going to configure and verify that MGCP registration. So the first task is to configure MGCP on the Call Manager. Now, at a high level, Call Manager includes several different configuration steps for implementing an MGCP gateway. Number one, you have to add the MGCP gateway to the call manager. Number two, configure the gateway in Unified Communications Manager with its appropriate configurations. Add your voice ports or voice modules to the appropriate slots based on the physical configuration of your MGCP gateway. Add the voice interface cards to those particular modules. And then finally, configure the MGCP endpoints themselves. So that's what we're going to do in this particular task. Let's go ahead and log into, we'll go back to PC1 and we'll do all of our configurations from PC1 here. We're going to log into our call manager, 10.1.5.5, and not the self-care portal, sorry about that. Let's go ahead and authenticate. We have to accept the self-signed certificate, which we'll do right now. And then we have to go to authenticate, and then we're going to add the gateway. All right, so administrator and C0LL at B. And then we're going to go into our device list, and we're going to add a gateway. Now we have a choice here. We could add an MGCP gateway. We could add an H323 gateway. We actually have a couple of different choices. And then, of course, if it's going to be an H323 gateway, then we actually have to select the appropriate type of device. In this particular case, we're going to be adding an ISR 4431. It's going to be running MGCP. The domain name is going to be sjc-gw.cll-collab.internal. We're going to give it a description of just MGCP PRI gateway. It's going to be in our primary call manager group. It's going to have an ISR 3NIM-MBRD, which is the motherboard slot, and then we're going to put in the card, and we're going to have an NI2 configuration. So the first step is to go ahead and pick the ISR 4431. If I was doing an H323 gateway, I would just simply select H323 gateway because Call Manager doesn't really care what the physical platform is. With MGCP, we actually care about what the physical platform is. So we're going to choose a 4431, not a 4331. So let's go and get the 4431. We'll click Next. The protocol is going to be MGCP. We'll give it a domain name of SJC-GW, which, by the way, happens to be the host name of the gateway itself. And we'll put in collab.internal, which happens to be the defined domain name on the gateway itself. If you happen to change either of those things, you need to come back into Call Manager and you need to make those changes on Call Manager. All right, we'll select our primary Call Manager group. We're going to go ahead and pick the motherboard, and we're going to change the signaling, ISDN switch type, to NI2. This would depend on what the service provider is providing for that ISDN connectivity. You'll have to identify that and define that based on that. All right. So now that we've added the gateway, the next step is to go ahead and add the VIC modules. And we're going to use a multiflex trunk card, a 2-port multiflex trunk card, specifically in this case. It's a network interface module, and in this case, it's a 2MFT T1E1 T1. So that means that we can provision this as a T1 card, or we could provision it as an E1 card. In this case, it's being provisioned as a T1. Also, depending on the device you have, depending on the type of router you have, the physical platform, you may need to define what type of modules exist, if they're recognized by the physical platform, and what slots they are in. If you go into the command line and you type the command show inventory, you can actually get that information, and it's that information that you're going to utilize that is going to get populated into this configuration page. What you have in this page obviously is going to have to match what you have in the physical platform. Now we're going to be configuring port 010 in this particular case. The protocol is going to be In this case, well, let me see. Are we defining this as a T1? I believe it's an ISDN PRI because that's what they defined in the topology. So we'll select an ISDN PRI. The device pool for this device is going to be San Jose because this is the San Jose gateway. The call classification is going to be off-net in this particular case. Anything that leaves the control that we have in our voice system is going to be defined as an off-net call. The media resource group list, this is what we need for doing things like conferencing, MTP resources, enunciator resources, and so on. And we're going to use the HQ. The location is going to be HQ. And as far as enabling status poll, we'll go ahead and set that on. But we're also going to configure the search space for this gateway. All right, and also the redirecting number, i.e. delivery outbound, needs to be enabled. So we're going to scroll down here and we're going to go into enable status poll. We'll check that. In addition, we want to go ahead and make sure that we display, well, let's set the calling search space for inbound calls. We're going to set this to Gateway Headquarters CSS. Now keep in mind, this is where you want to perhaps restrict the capability of this gateway because of for toll prevention purposes, which we'll talk about a little bit later on. All right, now we're going to be configuring gateway parameters, or we are configuring gateway parameters throughout this. It is best practice to enable the parameters enable status poll, display, i.e. delivery, and redirecting number enable status poll when you configure an MGCP gateway. The enable status poll parameter allows call manager advanced service parameters, channel B, channel maintenance, or excuse me, change B, channel maintenance status, and so on. All right. The IE delivery function outbound parameter enables the delivery of the display information element in the call setup message for the calling and connected party name delivery service. And then the redirecting number, IE delivery outbound parameter, indicates the first redirecting number and the redirecting reason for the call when the call actually gets forwarded. So these are really kind of best practice standards. Now, it doesn't necessarily mean that the call will fail if these particular functions are not selected, but they are best practice. All right. So we've gone through, we've enabled all of the features of the gateway itself. We already specified the calling search space, and let's go ahead and save this configuration. All right. We're going to save this configuration. Now keep in mind that MGCP is a client service type of protocol. The server, client server, excuse me, the server is going to be call manager, and it's going to be managing this gateway endpoint. All right. So let's go back to find our list here of our gateways. We should see the gateway listed in our configuration. We're going to go ahead and highlight this and then say reset selected. Let's try that again. Something weird going on there. So, all right, one more time. Reset, and I always like to do a restart as well, just to make sure that the gateway is going to be restarted. Now we need to check the status of the gateway. We list the gateway, and we can see the endpoints. If I go into the endpoint, I can then see the status of that particular endpoint. So if I click on See Endpoints, I can see the status presently is none, but eventually it should change, right? It should change. MGCP endpoints, in this case, is that shows a status of none because we have to enable MGCP at the gateway level as well. All the configurations on the call manager are done, but until we actually configure MGCP on the gateway side, we're not going to see anything. So that's our next step. After we've gone through all the process of adding the gateway and call manager, we need to now go to the iOS and configure the iOS gateway to register with call manager. Now, there are three ways that we can actually configure an iOS gateway to register to Call Manager through MGCP. We can use a configuration server to configure a iOS MGCP gateway. We can manually configure the iOS MGCP gateway, or we can use both a configuration server and manually configure it. Now, if I'm using a configuration server, I basically specify the IP address of that configuration server, which in this case would basically be Call Manager as providing TFTP services by using the ccm-manager config server command. And that's, for the most part, what you're going to do for an MGCP gateway. If we have more than one Call Manager TFTP server deployed, we can actually configure primary and secondary addresses as well. And then finally, we enable the configuration server features by using the command ccm-manager config. All right. Now, we can also manually configure it. We specify the IP address of the MGCP call agent, in this case, Call Manager. If we have more than one Call Manager, we can also specify primary and redundant call agents. So we would have the IP address of two different Call Manager call processing servers. And then we configure the MGCP parameters globally, like MGCP packet or MGCP RTP commands, and then we enable MGCP. Quite frankly, using the configuration server is probably the best option, assuming the appropriate ports are available and so on. There's really no reason not to use the configuration manager server option. So let's go into PuTTY, and we're actually going to go over to our San Jose gateway, which is really just router number 1 in this case. We'll go ahead and load that up and authenticate. And we're going to go into config-t. Well, let me show you the show inventory real quick. The show inventory command, as I said, gives you us the chassis, so we know what the chassis is. It also tells us what card is in the device, and then additionally, specifically, let's see if we see it here. We don't see the motherboard necessarily listed separately, but we do see the actual voice card. We can see there's a couple of other ports and stuff on here as well. So that show inventory command can be very, very useful for identifying what types of devices you have. So we're going to do MGCP call-agent, and our call agent, we only have one in this case, 10.1.5.5. CCM manager config server is going to be 10.1.5.5. And CCM manager, CCM manager is we're going to say, okay, let's go ahead and get the config from Call Manager. And then the last step, where we have two more, CCM manager, we're going to run MGCP. And then finally, we're going to turn on the MGCP protocol. Now, if I do a debug MGCP events, and I run MGCP, let me do a term mon as well. Do term mon. And I do MGCP, you're going to see that basically a whole bunch of transactional events are going to take place. The gateway is communicating with Call Manager is communicating with the gateway. You can see that the layer 2 interface for serial 010:23 came up. And that's pretty much it. The device is going to go through various configurations. It's going to download its config from Call Manager based on what we provisioned within Call Manager, including things like the switch type and so on. All right. Now, let me turn off the debug here, because MGCP is a very chatty protocol. And we're just going to verify the configuration by simply typing show MGCP. All right, if you go right at the top here, we can see the admin state is active, the call agent is 10.1.5.5, and we're running MGCP 0.1. All right, which indicates that the gateway did what it was supposed to do. Now, we could also go down to our Call Manager page. If we go back to our gateways and we refresh this page, let's go to find. we can see that the endpoint, the actual interface, is now registered with the publisher. All right, now if I go to device and gateway, I won't really see anything specifically within the device and gateway. Let's clear the filter here. I won't see anything specifically within the device and gateway. Here's the gateway itself. We do see the endpoint registered, but if I go into the gateway itself, I don't really see that the gateway is registered. It's because the endpoints are what are being controlled by Call Manager. So the endpoints are what need to be registered to the Call Manager. All right. Also, at the end of this output here, we can see that we have different payloads that are supported. We can see different transports. But most important, well, not most importantly, but certainly significantly, I can also see what the port number is that we're using for MGCP. In this case, TCP port 2427. Most of the call control protocols are going to be TCP based, not UDP based. Our media protocols are UDP based. Our control protocols are typically TCP based. So now we'll move on to task number 3, implementing our inbound and outbound PSTN calling. Unlike an H323 gateway where the dial plan is implemented at the gateway level, with an MGCP gateway, the dial plan is implemented within Call Manager. All right, so we're going to implement this inbound and outbound PSTN calling. We're going to create a complete dial plan with digit manipulation, call routing, etc. But all of this is going to be done within Unified Communications Manager. Now, there are many ways that we can actually manipulate digits within Call Manager to give us kind of a robust dial plan. We could do things like external phone number masks, translation patterns, digit stripping, and so on. With an external phone number mask, we can mask numbers based on call routing components going to the PSTN. So rather than representing the number as its internal DN, for example, for the caller ID information, the external phone number mask gets set on a line-by-line basis. And that's actually done, by the way, under the directory number configuration page to use that external phone number mask for that global PSTN route pattern. All right. The external phone number mask configuration can be applied to different call routing components and functions as well. We can apply these masks to route patterns, to translation patterns, to calling party transformation patterns, to hunt pilots, route group manipulation settings within a route list, automatic alternate routing or AAR functions, and so on. With translation patterns, Call Manager can use these translation patterns to manipulate dialed digits or dialing digits, or you know, the dialer's information, but mostly dialed digits, before we route the call to the destination. Sometimes the dialed number is not actually the number that the system uses to reach that destination. In other cases, the dialed number is not a number that the PSTN might recognize. We might have to expand that number or translate that number. So a translation pattern can be used to do this, but translation patterns can also be used for other features, right? We could create blocking patterns within the context of our Call Manager, dialing rules, all right? Configuration of translation patterns is like configuring a route pattern. Each pattern has a calling and called party information field, and specifically within that information field, we can do our transformations. The difference is that when Call Manager applies a translation pattern, it restarts the digit analysis process to perform another call routing process for the modified number. So it's not like we're actually just continuing the original calling process. We're actually starting a brand new calling process, and for that reason, we actually specify calling search spaces on our translation patterns. Now, the third option we have is to do digit stripping by doing things like discard digit instructions, or what we call DDI, to remove part of a dialed string. So, for example, if you're dialing an access code to route to the PSTN doesn't want to see that access code necessarily. So the DDI instructions tell us to go ahead and remove that access code from the number. Digit stripping is also configured under the called party transformations by selecting a DDI instruction. Digit stripping can be configured in the route pattern or even in a route group of a route list, for example. All right. Now, for the pre-dot DDI to work, the route pattern itself must include a dot. That dot is actually not dialed, but Call Manager recognizes that dot as a not a wildcard, but at least as a designation that we have some sort of access code to complete a call. All right, so we're going to configure a complete dial plan so we can place calls from the San Jose Lake location to the PSTN. And then for calls from the San Jose to the PSTN, we're going to translate the calling number of 11XXX to 408.555, 408.555 1XXX, masking only the last 3 digits. We're going to discard the access code 9 from the called number. That's our DDI instruction. And then for calls from the PSTN to San Jose, we're going to create a translation pattern to translate the called number from 408.555 1XXX to 11XXX. And that would be equivalent to like our direct inward dial transformation rule or translation pattern. All right. So we're going to implement the digit manipulation of the calling and called numbers for the outbound PSTN calls. We're going to do our digit manipulation of the calling and called numbers to translate, like I said, 11XXX to 408.555 1XXX. So let's go to our Call Manager administration page. And there's a couple ways you can do this, but usually when you're doing some sort of transformation based on a directory number, you're going to go into the device itself. We're going to go into CIPC1. We're going to go into the internal line. And in the directory number configuration page, we're going to basically specify an external phone number mask. Now, keep in mind as we do this that you could do this a more efficient way if all of the numbers were masked the same way. In this case, we only have one phone, so we're not really too concerned about it. But we're going to go ahead and specify the external phone number mask. We actually do that down here in the directory number settings. This only applies to the directory number on CIPC1. We talked about that in one of our previous lessons. So 408.555 1 capital XXX means I'm going to take the last 3 digits of the extension and I'm going to insert that into this number, and this is going to become my ANI information, my automatic number identification information, or basically the caller ID. All right. Again, you could do this on the phone individually. Oops, I put 405. Let me make sure I put the right number here. Or you could do this at the gateway level if the mask is going to end up being the same for every single phone. It just really depends on what's happening for that particular phone. We'll save that configuration. All right. Later in the lab, we're actually going to enable the calling party's external phone number mask parameter on the actual route pattern that we configure. So this is only the first step of that configuration. We still need to make sure that on the route pattern that we allow that phone number mask to be applied to the call. We're also going to do a discard 9 for the access code from the called number when we actually place calls to the PSTN. We're going to use that pre-dot discard or DDI instruction. All right, so let's go ahead and implement digit manipulation of the called number in our inbound PSTN calls. We're going to configure a translation pattern to translate the called number from the PSTN to the internal number of our CIPC-1 phone. So we're going to go to call routing. We're going to go to translation patterns. We're going to add a new translation pattern. We're going to translate 408.08555 1001 in this case. We could use X's here if we wanted to. If, for example, our DID block or our DID range was the same and kind of like the last 2 numbers mapped over to the last 2 numbers of the extension, we could use wildcards in the translation pattern. and say just put an XX for the last two numbers, and then on our translated called number section, we could carry over those XXs into the translated number. In this case, we're just doing a direct one-to-one translation. This is going to go into our headquarters PT, not device, sorry, gateway headquarters PT, because that's what the gateway is going to be able to dial. Remember, translation patterns need to be able to place a call. All right, now the description is just going to be 408-555-1001, DID to 11001. All right. Again, this is a case where we're not necessarily using wildcards. We do not want to provide outside dial tone for this. There's no access code. Anytime you don't have an access code, there's no need to provide outside dial tone. Also notice here that the urgent priority checkbox is checked. It used to be in the older versions of Call Manager, you couldn't even change that. We're going to go ahead and leave that checked. Translation patterns should have an urgent priority check. And then use calling party's external phone number mask. We're going to go ahead and check that. This is for a translation pattern. But remember, we're going to be setting those phone number masks on the phone themselves. And then we also want to make sure that the called party transformation, right here, is going to be the phone number, right? 11001. So that's what we're actually translating the DNIS information to, okay? Which is the dialed number identification service. All right. That's pretty much it. We can go ahead and save that configuration. Now again, if, like I said, if, let's say for example, the last three digits, well in this case, yeah, let's say the last three digits represented the extension. Like there was a direct mapping, we had maybe 900 DID numbers, 000 through 899, right? Or even 1,000, right? 000 through 999. And we said, okay, let's just go ahead and make sure that the last three digits of the translation pattern match or get mapped over to the last three digits of the user's extension, and then we'll just prefix that with an 11. We could put a 3 X's there, and then down here in the called party transformation, we could put 3 X's there as well. And then basically whatever 3 X's we received from the PSTN would get mapped over to the called party transformation. So we wouldn't have to create a separate translation pattern for every single individual number that's being translated. Okay? Our next step is to create the dial plan on Call Manager. We need to configure a dial plan with a route group and a route list and route patterns to route calls to those local, national, international, and emergency PSTN numbers from the San Jose location, and then we are going to go through a task of verifying the operation. So we're going to still be in call routing, but in this particular case, we're going to actually go ahead and create a route group. So we're going to go to route hunt and route group. Notice the kind of order of operations here. We create the route group first, or a local route group. Then we create the route list. Then we create the route pattern. All right. So, and if we're doing hunting, we do a line group first. Then we configure the hunt list. Then we configure the hunt pilot. So I'm going to go to route group. I'm going to add a new route group, and we're just going to call this the SJC route group in this case. And we need to add that circuit to the route group. All right, so I'm going to go ahead and click add to the route group, and the circuit gets added to the route group. Now notice the distribution algorithm, circular or top down. What you can do is you can instruct your service provider to use a bottom up selection method for the individual DS0s within the PRI, the D channels, if you will, and we can use the top-down function for outbound calling, so that the lines will get seized in the opposite direction. Generally, it shouldn't really matter. The gateway should be able to understand what the best way to seize a particular circuit or individual channel within that circuit should be. All right, so now we've got our gateway configured. Now we're going to go in and we're going to go to our route list. Now I know in this particular case we don't really have different gateways that we're selecting, but so in other words we could actually take those route patterns that we're creating, and we could point them directly to the interface. All right, but if you point a route pattern to an interface, in the future you can no longer reference that interface from a route list, or in a route group, I should say. So it's better to build the structure first, and then based on that structure, we're going to go ahead and even though we only have one interface within the route group and really only one route group within the route list, as long as that structure is built in, if we add another circuit later or a SIP trunk or something else to the route group, we don't have to go back and rebuild or reconfigure all of our patterns. We can, because it's already pointing to the route list. Does that make sense? So let's go ahead and reset the route list. Again, when you're, I don't know why the lab is doing that. Reset. All right. Whenever you make changes to a route list, you always have to reset it. I've run into that a few times where I forgot to reset the route list and it doesn't work. All right. So again, you could point a route pattern in this case directly to the trunk, to the PRI. But if you do that, then you can no longer reference that PRI from a route group route list configuration. So it's better to build that structure in place from the beginning. All right. Our next step is to go ahead and create our route patterns. We're going to go route hunt, and the last step is to create a route pattern. See if we actually have any route patterns defined. No patterns defined as of yet. So we're going to go 9.bracket 2 through 9. This is going to be our kind of national dialing pattern, 2 through 9, not 12 through 9. It wouldn't work anyway. It's supposed to be a single digit, 2 through 9. Now we're trying to make the pattern as specific as possible. Area codes and prefixes can never start with a 0 or 1. So this is a more specific representation. 1, 2, 3, 4. All right. We're going to go ahead and put this into the device headquarters partition. We're going to say that this is our local calls route pattern, which again is going to map over to that specific PSTN phone. Now notice here when I select this, I don't see the gateway anymore. See, we have gateway and route list. Because that gateway interface was added to the route list, it's no longer referenceable or no longer selectable from the list here. So it can only exist in one location. The call is going to be off net. We are going to provide outside dial tone. Again, we want to use the calling party's mask, which was configured at the device directory number level, right? We did that at the directory number level. And then our next step is to do our discards. Called party, we're going to do a pre-dot discard, meaning that basically anything that comes before the dot is going to get removed as the call gets sent over to the PSTN. All right. Now, in this case, it'll tell us, authorization code is not implemented, etc. That's fine. We don't really need that. We did talk about the concept of forced authorization codes as well as client matter codes, but we're not using those in this particular exercise. So we're going to go ahead and add another pattern now. This is going to be our national calling pattern, which is our 9.1, 2 through 9. Actually, you know what? Let's do this a different way. You actually have the ability to copy a pattern that's already created. And since we're only changing a couple of things about this pattern, it kind of makes more sense to go ahead and copy it. This is going to be called our national call route pattern. National. We're still doing the pre-dot discard. It's still going to the San Jose route list. We're still doing off-net. We're still providing outside dial tone. We're still doing the calling party transformation. And we're still doing the pre-dot discard. So by copying it, not only does it make our life a little bit easier, but it also ensures that we have the appropriate settings and we're not missing anything as we're going through the process. All right. So if I go back to my list now, I can see the two patterns. We're going to go ahead and create another pattern. In this case, this is going to be our international pattern, 011 exclamation. All right, this is international calls. And pretty much everything else, international, everything else is going to be the same. We're still doing the pre.discard, etc. Now this particular pattern uses kind of a generic wildcard. The exclamation point is any number of digits. So there will be a T302 timer issue with this particular pattern. We could create another pattern. In fact, let's go ahead and do that. That has the termination code built into it. So if somebody didn't want to wait for that T302 timer, they could actually just simply dial the pound as well as part of the number. I won't even change the name of this because it's still an international pattern. All right, so we're kind of going through the process of defining all of our patterns. Now, we didn't in this particular case talk about the concept of local route groups, at least from a demonstration standpoint. I would probably be inclined, even if I have a single site, to go ahead and configure local route groups, because if I do add more sites later, again, it's the same concept of building for the future, right? You don't want to build for right now. You need to plan for growth, plan for change in the future. So you want to make sure you're implementing the design and the architecture in a way that if somebody says, oh, we want to add this feature, or we want to change this restriction, or we want to control this more, you already have the configuration in place that's going to allow that to happen. It's kind of important, actually. All right, so even though we could do it a simple way, we really, in this case, could just create one generic pattern and say, just send all those calls to the PSTN because we're not really defining any search spaces and whatnot. But let's go ahead and create our 911 pattern. Again, the idea here is that you want to make sure that you have the structure in place to be able to support all this routing. Now, in this case, we are doing a 911 pattern, which will have it really shouldn't overlap any of our other patterns, but we want to go ahead and check the urgent priority box. So if there is an overlap, it's not going to affect emergency dialing, okay? Basically, the urgent priority checkbox says, as soon as you see a 911, go ahead and use this configuration to place that call. There's no pre.discard option here because we don't have a dot in the pattern itself. We'll go ahead and save this pattern. Now, we could also do a 9.911 pattern. It's generally recommended that you do a 9.911 pattern because people are used to using the 9 access code. You don't want them to run into a situation where they're in the habit of using the access code and then they try it and it doesn't work for 911. So that's why we put the 9.911 in there as well. All right, mark that one as urgent priority as well, just in case there's some overlapping patterns with that. Now, we could create other patterns for other service numbers like 611 or 411. We could create individual toll-free based patterns. There's all kinds of patterns we can actually create. In our particular case, we're not necessarily concerned about that in this particular case. All right, so what we have left now to do is just basically test everything. So let's go ahead and go into CIPC1. Let's go over to CIPC1. I was already on PC1. Let's go ahead and minimize this. We're going to place our test call. The first number we're going to call is 9408 555 1234. The call should go through, and we can see the call ringing through. Notice the number presentation here includes the phone number mask that we applied, right? We already matched the route pattern. The call is being sent through. All right, so let's go ahead and answer that call and end that call. Now we're going to dial the international, which is 91919 555 1234. And that call should ring through. We can see that call coming in from John Doe. All right, we'll answer that call and hang up that call. All right. And that's going through that gateway as well. Now we're going to call an international number. Let's go ahead and end that call. We're going to call an international number 9011442079460132. All right, now in this case, we should see that T302 timer, about 15 seconds or so. I think in this particular lab, it's set to 10 seconds, but we can see that call coming through on the international line. We'll go ahead and end that call. All right, we're also going to go ahead and test our 911 calls. So let's dial 911. That call should ring through immediately. We can see that coming in on the emergency line. We'll answer that call and end that call, and we'll try our 911 pattern. 911 pattern. And that call should ring through to the emergency line as well. We'll end that call. All right. Now, what if we place a call to the local line, right, to our PSTN simulator? Let's go ahead and try that. So we're going to dial just a 1408. All right. Notice here that the call fails, right? Because we didn't dial the PSTN access code. But now let's go to our PSTN phone and let's dial our directory number. So we're going to go into our national number 1408. So this would be like somebody dialing from the PSTN to our DID number, and that should ring through to PC number 1, and we can see that call coming in. Now notice that the caller ID in this particular case isn't being presented correctly. 5552. Let me try it from just the main line here. That would be something that would be configured on the PSTN side. 1408 555 1001. See how that call, yeah, so that call comes in as 408-555-1234. So it just, the way the dial plan is set up on the PSTN gateway doesn't do the digit manipulation with the transformations like we would want in this particular case. But it looks like all of our calling is working, and that's pretty much it. That is how we configure an MGCP gateway. There's obviously some additional troubleshooting and configuration components that you can do as part of this process, but that completes this discovery. We're going to wrap up this module by doing our summary challenge, and then we're going to move on to implementing voice gateways. Although this is a voice gateway, we're going to be talking about dial peers and manipulating digits and whatnot on a voice gateway. So we'll see you guys there.